So we're going to look at section 2.5 and also 3.1. So the first thing we're going to look at is solving inequalities that aren't necessarily linear, but maybe quadratic. Okay, we won't look at anything higher than a quadratic in general, because this method that we're going to learn relies on factoring. And right now, quadratics are pretty much the most complicated thing that we know how to factor somewhat quickly. So we're going to look at a formula, first of all, for projectile motion. It's the same formula we've done before. The negative 16t squared plus b sub 0 t plus s sub 0. So s of t, that's the calculation for your height in feet. V sub 0 is the initial velocity that the object is moving at. And S sub 0 is an initial height. So we did this, I want to say back in chapter 1, when we started learning about quadratics. So we're going to look at it again, but we're not going to calculate when the object is exactly at a certain height. We're going to calculate when the object is either less than or greater than a certain height. So we're going to do it with an inequality today. And we're going to use the calculator to do this one. So this one says that we're throwing a ball straight up from ground level with an initial speed of 80 feet per second. Because it's ground level, what does that mean my initial height is? Yep.
You have initial height of 0.
Initial height is 0, so we don't even need that in this problem. So let's write down a formula for my height using the projectile motion equation and the information they gave me. So it would start out S of t, and then what comes right after the S of t in the projectile motion equation? This part never changes. Yep. Okay, so negative 16. What comes after that? Negative 16. Squared, yeah. So negative 16t squared plus and what would come right after the negative 16t squared? And our velocity sub 0 is 80. There you go. So plus 80t. So there's an equation that represents the height of this object based on the information they gave us. Now, I want to know when the ball is at least 64 feet above the ground. What does, in terms of inequalities, what does at least mean? Yeah?
Make that number higher.
That number or higher, greater than or equal to. So I want to know when the height is greater than or equal to 64. So take your formula for the height, which is right there, and fill that in for height. When is the height greater than or equal to 64? So I don't really need to write, well, I guess I can write it, but it's negative 16t squared plus 80t greater than or equal to 64. So what we'll do is we'll graph it. We're going to do one side in y1, other side in y2. So I'm going to put negative 16x squared plus 80x. And I'm going to put a horizontal line at 64. Is the standard window okay? No. First of all, x is time. What values of time should we focus on? Yep.
Positive
Should
values.
focus on positives. Height is also a value we should focus on positives. Negative 10 would mean it's like below ground. right? So it's not, we're not going below ground. So it's 0 for minimum height. And at my maximum height should be what number? It at least has to be this number. Yeah? At least 64. We should probably go a little higher, maybe like 80. It doesn't really matter if we see the top of the parabola. All I care about is that I can see one thing in particular. So I don't know how high this goes, but that's fine. All I care about is when it's above 64. So what do you think I want to calculate here? Yep.
The intersection of those two lines.
Yeah, let's do the intersection. So I'm going to do the one on the left. Actually, I'll do the one on the right because I'm closer to it. And I get 4. So that means on the way back down, this object goes below 64 feet at the 4-second mark. So that's the right end of my interval. And if you calculate the other intersection, you end up getting 1. So it's 1 and 4. So that's the time on the way, that's the time in this problem when the ball is above 64 feet, between above or equal to 64 feet. Any questions on that? All right. Now, I want to answer another question. And I want to know, how long is the ball in the air? Now, think about what that means in terms of the height. If the ball is in the air, then what do you know about its height? Yep.
Greater than 0.
It's greater than 0. So this time, we want negative 16 t squared plus 80t to be greater than 0. And this is going to lead into the method we're going to learn today, which involves factoring. We need to factor this left-hand side. The only type of factoring we can do there is a GCF. Does anybody see what the GCF is for the left-hand side? Yeah. Okay, so for the number part, it's 16. I'm actually going to pull out a negative 16. You'll see why. You could do just 16. But I'm going to do negative 16. And I want to do something else with it. So I'm going to leave a little more space. Does anybody see something else I could pull out with the negative 16?
Yes.
You could pull out the AT.
I could pull out 1t. If you do that, what would you be left with inside the parentheses? Yeah.
T plus 5.
T what?
Plus 5.
Not plus 5. Because remember, this is a negative.
Oh, minus 5.
So that would be a minus 5. So now when we do a negative times a negative, we get our positive back. Now, we have two factors there. You don't need parentheses around this one, but just to be clear which one I'm talking about. The factor in the red parentheses is negative 16t. The factor in the black parentheses is t minus 5. What kind of number did we just say t is always going to be? Yeah?
Positive.
T is always a positive number. So think about what happens to the first factor if you fill in a positive number for t. What would happen to the thing inside the red parentheses if you fill in any positive number for t? What would the result always be? Yeah?
A negative.
You're always going to be getting a negative for that factor in red, because t is always a positive. Now, look at the big picture now. Something times something has to give you a positive, because greater than 0 means positive. This is negative. So what would this have to be? So this times this has to come out positive, yeah?
Less than 5.
So in, not even specific yet, but in general, you want this entire thing to come out what?
Negative.
Negative, yeah. This is automatic. You can't control that. But this, we have to pick a value that would make this second factor negative. So then a negative times a negative gives you a positive. And as Dennis just said, the idea is, when is t minus 5 negative? How would you force this factor to be negative? Well, when is t minus 5 less than 0? T would have to be less than 5. Which means this object is in the air for less than 5 seconds. It's like 4.9 repeating. At exactly 5 seconds, it hits the ground. Now this was only doable because we were able to factor it and think about it that way. And the method that I'm going to teach you right now in general relies on factoring. So this method of solving higher order inequalities, which is what we're looking at today, involves factoring. So first of all, what's a factor? Factoring is when you end up with something like this. That's an example of two linear factors. And anytime you factor something and you look at the factors, there is a number you can plug in to each factor to make it 0. Exactly one number. What could you plug into the first factor to make it 0? Yep. 3. And how about the second factor?
-4.
-4. So now we know exactly the number you can plug in that gives you a result of 0. What we're more interested in is, when do you get a positive result and when do you get a negative result? Well, that's the boundary. 3 is the number you plug in and you get a 0 result. If you plug in a number bigger than 3 into this first factor, you'll get a positive result. If you plug in a number less than 3 into this factor, you'll get a negative result. That's what we're interested in. Where do we get a positive? Where do we get a negative? Right, here's another example. 2 more. Actually this one's the same. T plus 4, x plus 4. But here's another one. T minus 1. That factor would have a value of 0 if you plug in the number 1. So what we're going to do now is, after we know the value you can plug in to get 0, we're going to mark that on a number line. The value that gives you 0. After you mark the spot that gives you 0, then you're going to split your number line into 2 sections. Here's your number line. Here's the spot that gives you 0. I have a left section, and I have this right section. I want to know what the sign is going to be if I plug a number less than -4 into that formula. Well, it would be a negative result. If you plug a number below -4 into what I just circled, you'll get a negative result. If you plug a number higher than -4 into that thing I have circled, you'll get a positive result. That's what we need to do for each fact. Make a number line, mark the 0, and determine the sign in each section. Now, once you do it for each individual factor, you're going to have as many number lines as you do factors. So when we do this problem in a minute, this one's already factored for you into 3 factors. We're going to end up making 3 number lines. X plus 3, x minus 1. Once you make a number line for the individual factors, we need to combine it all together into one number line. You could try to jump to the final number line right away without doing the individual number lines. And after you've done it a little while, you can kind of do that. But my suggestion at first would be make the individual ones and then combine them to make one. And that one number line will show you your answer to the problem. All right, so we're going to take this last step until you see it done in an example. Might seem a little tricky. There's the problem we're going to look at. I want to know where 2x squared plus 9x minus 5 is above 0. Where is it a positive result? So the first thing we have to do for this method to work is factor the left-hand side. If I start to factor that, can someone tell me what my first two terms would be inside each parenthesis? Yeah. 2x and x. How about my signs? I have a negative constant. So what does that mean I need in the parentheses to multiply two things and get a negative? Yep.
A positive and negative.
Yep, and I would do them in that order. And now two numbers that multiply to give me 5. No? 1 and 5. And I would do them exactly the order she said. Let's check. 2x squared plus 10x minus 1 is plus 9. Yep, perfect. So now we're going to make two number lines, one at a time. Let's start with 2x minus 1. Mark a spot where you're going to put the 0. It doesn't matter where you mark it. You just mark it right in the middle. But what value would you fill in for x here? So when you do 2 times something minus 1, you get 0. Yeah. 1/2. Good. Now, if you pick a number smaller than 1/2, so if you pick a number in the left section and you fill it in for x, what will the result be? A positive value or a negative value? Okay. Negative. You could try one. Pick 0. 2 times 0 minus 1 is a negative. If you pick a number bigger than 1/2 and plug it in for x, the result will be positive. Good. That's all you're doing. Now do it again for x plus 5. It's a totally separate number line, so it's not drawn to scale with the other one. Just mark the 0. I just put it right in the middle. And now we're looking at the root here. Livy, what would you plug in to get 0 in this factor?
5.
5 plus 5, it would give me 10.
Negative 5.
Negative 5. And Luke, if you pick a number smaller than negative 5, get a negative value. And Cassidy, if I pick a number bigger than negative 5, I would get
0.
positive value. Yeah, that's okay. So yeah, we got a positive. Is there any question on those number lines? Now the last step, combine them to get the final answer. So we're going to make one number line that represents the product of these two. So mark both roots on the same number line. Doesn't have to be to scale, just mark both of them. They do have to go in order from low to high. This is negative 5. This is 1/2. Now, what you've done is you've broken the number line into 3 parts. We're going to figure out what happens in each part. Let's start with negative 5 and below. If you look at the top number line, if you are at negative 5 or below, what section would you be in the top number line? Yep.
Negative.
Negative. So you'd have a negative. times. Now let's look at -5 or below in this bottom number line. If you were at -5 or lower, what section are you in the bottom number line? About this? Yeah, that's a negative. Now, what are you doing with those two negatives? You're multiplying them together. You have something times something. So a negative number here times a negative number here would ultimately result in a positive. You can try it. Plug -10 in for x in both of these. You will get a positive result. Next section, between -5 and 1/2. Jared, if we look at the top number line, what section am I in if I'm between -5 and 1/2?
What section are you in if you're between -5 and 1/2
Yes.
and positive?
No, -5 would be over here.
Negative.
Yes, you're in the negative section. So that's a negative. What about in the bottom number line? If we are between -5 and 1/2. That's positive. And you're going to take a negative result times a positive result, and that would give you, that'd be negative. Now let's see what happens if we pick a number bigger than 1/2. Charisma, in the top number line, if I pick a number that's bigger than 1/2, what section am I in?
Positive.
Yep, positive. And Renee, if I pick a number bigger than 1/2 in the bottom number line,
Positive.
I'm in the positives. And you're taking a positive result times another positive result, that would give you a positive result. So now we know where the final answer is going to result in a negative number and where it's going to result in a positive number. We have to look at the question. They want to know where the result is positive. They don't care where it's negative. Where are we greater than 0? So that would be this section or that section. So we have two different areas we could pick a number and it would result in a positive. This first section is from -infinity up to and not including -5. Everything from -5 and down. Or, anyone think they could give me the other section? Yes?
It would be 1/2 to infinity.
Yeah, from 1/2 and up. The only place you cannot pick a number is between -5 and 1/2. That would result in a negative answer. And that's pretty much how you do a sign pattern. Okay, we'll try one more of those, but that's the idea. Any questions? Notice this depends on factor. If you cannot factor, you cannot use this method. All right, let's look at this one. This has already been factored for you, so you can jump right to the number ones. What could you plug in for x to make that first factor 0? Yep, 0. What could you plug in for x to make the second factor 0? Yep, -3. And the third factor? Cassidy? 1. So I know how to make each factor 0. I'm more interested in how to make each factor positive or negative. So Genesis, if I pick a number smaller than 0 and fill it in for this, what kind of result will I get? Yep, negative. If I pick a number bigger than 0? Exactly. If I pick, Jillian, if I pick a number smaller than -3 and fill it in here, I would get a negative. Bigger than -3, I'd get a positive. And it's the same thing here. So now, combine those together to make one number line. Ultimately, we are interested in positive values. Again, if they flip it and make it less than or equal to 0, then we'd be interested in negatives. So, this time the number line is broken into 4 sections. And we've got -3, 0, and 1. Let's look at the less than -3 section in each part. All right, top number line. Well, Luke, if I look at the top number line, and I was less than -3, what section am I in? I'm definitely into the negatives. Okay, Christian, if I look at the middle number line, and I'm less than -3, what section am I in?
Negative.
I'm still in the negatives. And Cassidy, if I look at the bottom number line, and I am less than -3, what section am I in? I'm in the negative section again. So that would result in a negative times a negative times a negative, which is a negative. Now, we don't really have to check every section. The sections always alternate. And if you look back at the last problem, that's what happened. So my advice would be check the first 2. And if those alternate, then you're probably pretty safe to assume you found them correctly. If you ever get like negative, negative right in a row, no, something's wrong. They always alternate. Now I forgot, what do they want to know? Positives. That means you could be in this section or this section, but this time it's greater than or equal to 0. So how would you describe the numbers in, we'll call this interval 1, that's interval 2. How would you describe the numbers in interval 1? I'm looking for intervals with parentheses or brackets. Yep.
So it's included.
It is included, yes.
So a bracket is -3, comma, 0.
Okay, so that covers interval 1. Or, how would we write interval 2? So this first interval was bounded. Yep.
A bracket on 1, then comma, infinity.
And the second interval is unbounded. 1 to infinity. Any question on that? So again, works fine as long as you can factor. Well, if you can't factor, then what we'll do is use the calculator. This is hard. I mean, it might be impossible to factor. It's not something we could even try to do easily because it's got a cube term in it, and it has every term going down. If all it had was a cube term, and it didn't have the squared, the linear, and the constant, and this other side was simpler, so basically if it was a completely different problem, then we might be able to factor it. But that's not factorable. So let's put this in. This time, clear your y1 and y2. Put in x cubed minus 2x squared minus 5x plus 7. And the other one is 2x plus 1. So the graph in blue is my cubic. That's going to be the one that turns. The graph in red is going to be linear. It's going to have a slope of 2 and a y-intercept of 1. I am looking for where the cubic is above the linear. I'm going to do zoom 6. There's my cubic. And I want to know where it's going to be above this red line. So let's look at that. When you describe this, how many intervals are we going to need to write the final answer for where the graph in blue is above the red? Yeah? Can you explain to me what you're thinking about why you said 3?
There are 3 intersections, so there would be 3 times its above.
So there are 3 intersections, but think of it. Think of it like if you were tracing your pencil when the blue is above the red. How many sections would you draw if you were going to trace over the section where the blue is above the red? Yeah?
Just
2. You would trace, does it say less than or equal? Or greater than or equal? This section, the blue is above the red. So I need to describe all the x values between here and there. And then I need to describe the x values from here, and that just keeps going forever. So there are 2 sections where the blue is above the red. What do you think I'm going to have to find 3 times? Yeah, right? I need the intersection. So I'm going to do second calc, intersect, pick a point that's over on the left side. I did the left one. If someone can do like the middle or the right one, that would be helpful. So from negative 2.26, and I can include it because I have the equal to, up to this next x value. That's a section where the curve is above the red line. What's that other x value right there? Yeah. Okay, so 0.76. So if you pick an x value between negative 2.26 and 0.76, the blue is above the red. Or you could pick an x value from here and beyond. What's that last x value?
3.507.
Looks like it comes down like that. So you said 3.507?
Yeah.
So 3.51. So from 3.51, oops, I don't want to put that there. 3.51, and how high of a value could I pick? To infinity. That's never coming back down. From here, the blue one is always above the red one.
So it's 4 because they're facing, there's like 2.
Yeah, whenever you have multiple intervals, you put or because you could either pick an x value here or here. Now, if they said, where is it below? If they took this sign and flipped it, well, then your intervals would just be switched. It would be from here down, so negative 2.26 going down forever, and between 0.76 and 3.51. It's below the line. So the key is you have to find the intersections each time. Any questions on that? All right. So that's 2.5. So the last thing we'll finish up with, the last 35, 40 minutes, is the first part of 3.1. So this is on what we call polynomials. So this last graph that we just looked at in blue, that is a polynomial. The one in red is also a polynomial. Polynomials, the nice thing about them is we don't really have to worry about dividing by 0 or square roots of negatives. That never happens in a polynomial. So when we start to talk about domain, it's very easy to figure out the domain of a polynomial. The two things that you're not allowed to do never happen. So think about what that would mean about the domain. We'll get to that in a second. But that's the general form of what a polynomial looks like. So a specific example could be like 5x cubed plus 8x squared plus 3x plus 7. The idea of a polynomial is the exponent should be going down as you write it. Usually the last thing you would write, if you have it, is the constant. You may not have every single exponent from the highest term to the lowest. This is a polynomial. We skipped the x squared term and we skipped the x term. That's fine. I'm just trying to show you that the pattern is the exponent goes down one each time. Unless it's not there at all, then you skip it.
Are there tops?
That just means you could have, I mean, like if this was like a 50th degree polynomial, you might have something to the 50th, and then you might have something to the 49th, and then the 48th, and the 47th, all the way down to just your constant. The key thing in a polynomial is the exponent on the variable cannot be a decimal or a fraction, and it can't be negative. It has to be a non-negative integer. This is not a polynomial. X to the 3.5 power. Nope. X to the negative 2 plus 7. Nope, not a polynomial. You can't use negative numbers, and you can't use fractions or decimals. So, assuming you don't write something like this, it's an example of a fourth degree polynomial, almost. The problem with that is it's not really a fourth degree polynomial. Why not? Yeah.
Because there's a zero multiplied by the cube, the power of the 4.
Yeah, if you put a 0 in front of this first term, then why did you even write it? You might as well just skip it and not even write it. So as long as you don't do that, then as long as this very first number is not equal to 0, then the very first exponent that you see, assuming you wrote it in order from highest to lowest exponent, like this problem, the very first exponent you see is called the degree of the polynomial. This particular polynomial is a degree 3. Does anybody know the name for a third degree polynomial? Yeah? So trinomial is how many terms it has. So this has 4 terms. So a trinomial would be like this. This would be a third degree trinomial. This would be a third degree binomial. This would be a third degree monomial. That's not, doesn't exist. Okay? So, anybody else know another name for a third degree? Yeah? Cubic. Yep. So degree 3 is cubic. How about degree 1? Yeah? Linear. Degree 2? Yeah? Quadratic. Degree 3 is cubic. How about degree 4? Degree 4. Degree 4 is quartic. I don't think they use any names beyond that. So if you had degree 5, degree 6, you would just say it's a degree 6. Yes?
Why is 2 considered quadratic? Like, I mean, I know because it's the quadratic equation, but like, why is the Why is it quadratic instead of quad?
So why is it, I mean, what would you think it should be called? Like,
Well, because cubic is the cube root or cubic something.
so do you think it should be called like squaric or something?
I don't know, but it makes more sense.
Yeah, I don't.
Like the quadratic equation in general, like it makes
Quadratic.
sense. It's just why name it that?
Yeah, I don't know. When they have a power of 2, I mean, we do say,
Because then 4
like,
is
yeah, when you have a power of 2, you say that that's squared.
Yeah.
And when you have like a power of 3, you say that's cubed. So cubed, cubic kind of sounds the same. But a power of 2 is called quadratic.
Square is a quadrilateral.
Yeah, I don't know. It's a good question. This I kind of hinted at already, the domain. Polynomials have a very simple domain. It's all real numbers. Because the two things that you're not allowed to do in a polynomial are divide by 0, can't do that, and you can't have square roots. So if you're not allowed to have square roots and you're not allowed to divide by 0, then there's nothing that would mess up the domain ever. So the domain is all real numbers. But the range depends. It has a lot to do with whether the degree of your polynomial is even or odd. If it's odd, you generally get a pattern like this. One end goes up forever, one end goes down forever. If it's even, usually you get a pattern like that. In general, both ends either continue up, or you could flip it, and both ends would go down. So when a degree is even, you've got to pay a little more attention to the range. When it's odd, it's going to go up and down forever, which means it's all real numbers. So domain and range of polynomials is much easier than some other types of functions. So that's the general look of a cubic. One end goes up, the other end goes down. It might take a couple turns in the middle. It might not. Depends on the problem. Now, if you look at how many times the graph turns, you have 2 turns. What's the exponent on a cubic polynomial? What's the degree? I'm sorry. Yeah. Third degree. If you subtract 1 from that exponent, it tells you how many times the graph could turn. Not how many times it will turn, but how many times it could turn. So when we think of a 4th degree polynomial, how many times could it turn? Yeah. Could turn 3 times. And that would result in something that looks kind of like a W shape. The important thing with a 4th degree, that's an even number, 4. Either both ends are going to continue upward, or both ends are going to go downward. So when you want to find the range, if you're dealing with a 4th degree, because it's even, this particular one has a minimum, but it'll go up forever from there. It could also have a maximum and go down forever. But an odd, up and down forever, does both. Now, I'm not going to get into like a 5th degree, but a 5th degree, it kind of looks like a 3rd degree, but it can take 1 more turn if it wants to. It could go like this. The important thing is 1 end goes down, 1 end will still go up in a 5th degree. All right, so let's graph this and see if we can find the domain and the range. Well, what's the domain? Yeah. All real numbers. It's a polynomial. So you can plug in any number you want and raise it to the 4th power and then add that number cubed times 5. That's fine. So domain, all reals. Now, based on what I said earlier, this is an even degree. Is it going to go up and down forever, or is it only going to go in one direction forever? Yep.
Just in one direction.
It's only going to go in one direction forever. To figure that out, we make a sketch. So type it in. Minus 8x plus 1. Let's do zoom 6. All right, well, I can definitely see what direction it's going in forever. It is going up. I can't see the minimum. I need to figure that out. So let's try negative 20. And now it should be good enough that I can see the minimum on the screen. Perfect. So let's calculate the minimum of that left-hand value. Okay, that goes down lower. Second calc, minimum. Pick a point that we know is to the left. Pick a point to the right. And do your guess. Now, let's be clear about what the minimum is versus where the minimum is. The minimum there is negative 11.95. That is the lowest that it goes. Because we're talking about range. Range is what the minimum is. Domain would tell me, x would tell me where it is. So if I wanted to get a value of negative 11.95, I would plug in negative 3.25 for x. I don't care about the x. I'm not interested in the x. So the range is from negative 11.95. And how high is it going to go? Yeah, go ahead. It's going to go to infinity. It's just going to keep going up forever. Infinity is always a part of the range of a polynomial. Somewhere. Sometimes they're both infinities, sometimes it's just one of them. But it's always in there. Now, when we look at that graph, there were three special things. One here, here, and here. I'm going to tell you what those three things are called. You might have an idea already. Those are called local maximum or minimums. Anywhere that a graph turns, you get a min or a max. Local max, local min, max, min, max, min. When I have a local maximum or minimum, I'm not saying that this value is the lowest. I'm saying locally it's the lowest. Locally means exactly what it sounds like. Okay? It means it's in a small area. So a local minimum is a value that's lower than everything around it. A local maximum is higher than everything around it. If you had something like this in a parabola, that point right there, you technically could call it a local minimum, but this is also called a global minimum. Because not only is it the lowest value in this area, it is the lowest value ever. That's called a vertex. Yep, a vertex is a specific example of a local minimum or maximum. Or it could be a global minimum or maximum in the case of a parabola. So local maximum, a point that is higher than everything else around it. What does around it mean? Well, whatever you want it to mean. There's no specific thing for that. And then local minimum, that's a point that's lower than everything else around. So what you might see for directions either in homework or on a test is it may say find all local extrema. Local extrema are maxes and minimums. If you're dealing with a line, tell me, what do you think about lines and local maximums and minimums? If you draw a line. Yeah.
Well, they don't turn at all because it's just a straight line, so there wouldn't be any like min or max except for how far it goes. Like if there's an endpoint, then I guess that would be something. But if it goes forever.
Yeah, if it's a line and it goes forever, then there is no minimum or maximums in a line. The simplest polynomial you can have with a minimum or a maximum is a quadratic. All right, let's try finding minimum. We just did it on the last one, but practice it one more time. So x cubed minus 4x. You know what? I'll do the minimum. If someone else can do the maximum, that's the next question. So that would actually, you know what? I remember the min and max are symmetrical here. So once I know the minimum, I know the maximum. But you could try it if you want. So second calc, minimum. And we have to hit enter 3 times. To the left. To the right. I think I got it. Enter. And we get a minimum of, well, you tell me. What is the minimum? Christian?
-3.08.
So we have a local min at negative 3.08. Local min, I'm going to say it this way, local min of negative 3.08. And this occurs at x equals 1.15. So that answers both questions. What the local minimum is and where it is.
Isn't that the same? Oh no.
The what it is the y value, the where it is the x. Some people you can't mix that up. And the maximum, it's symmetrical, I think is negative 1.15 for x and positive 3.08 for y, if I remember right. So I'm going to skip the maximum. So the last thing, if you can figure out local minimums and maximums, that can tell you where a function is going up compared to where it's going down. Yeah?
Question about the last thing.
Mm-hmm.
Are all cubic functions symmetrical?
No. Nope, good question, but definitely not. That one just happened to be. Okay, so if you look at this one, where is that function going up? Like, where is it increasing? From where to where? Yep. From B to, so from A to B, it's decreasing.
Oh,
B to C. So when you read the graph, you always read it to the right. So B to C, definitely increasing. Where is it decreasing? Yeah. Yep, I agree. C to D. Anywhere else?
A to B.
and A to B. Now, look at one of those points where it goes from increasing to decreasing. Like point C. What do you get at point C because it goes from increasing to decreasing? What special thing occurs at point C? You get a what? Yeah? You get a maximum. Anytime a function that's a polynomial goes from increasing to decreasing, you just created a maximum in your function. Whether it's global, whether it's local, I don't know, it depends. But when you go from increasing to decreasing, you get a maximum. How about when you go the other way? From decreasing to increasing. What is created at the point where a graph switches from decreasing to increasing? Yeah. You get a minimum. So where a graph switches its slope from a positive number to a negative number, or from a negative number to a positive, you create an extremum. So I want to finish up, I want to use that same graph that we already have in here. And I just want to look where this graph is increasing, where it's decreasing. We already calculated one of the values that we need. So find the interval on which this graph is increasing and decreasing. Since this one is symmetrical, I already know the other one. This point right here is going to be negative 1.15, comma, negative 3.08. Can somebody give me one interval in this graph where it is increasing? Remember, you give me an interval, you're giving me x values.
From negative infinity to negative 1.5.
Perfect. So this graph is increasing from negative infinity to negative 1.15. And there's another interval where it's increasing as well. Yeah.
From negative 3.08 to positive infinity?
So remember, when you give me an interval, you're always using which value? Negative 3.08 would be over here.
A little lost. Even numbers are throwing me off.
Anyone just yeah, so I just
Is it 1, 2?
1.15.
Yeah.
Yes, you always use the x value when you describe an interval. So if you pick an x value from 1.15 up as high as you want to go, that would put you on this section, which is increasing, and the first one puts you on that section. So this is increasing, that's increasing. This section in the middle is decreasing. What's that interval in the middle? From what to what? Yep.
Negative 1.15 to 1.15.
Yep. Negative 1.15 to positive 1.15 describes where it's decreasing. So we have an increasing, decreasing, and then increasing again. And that's all based on local mins and maxes. Any questions on that? Libby, do you have a question?
I just don't get it.
So if you had a graph like, let's just do something that's not decimals. Let's call this 2, -1, -2, -3. And I asked you where this graph is increasing. Well, we know it changes right there, and it changes again right there. This is the section where it's increasing. This is a section that's decreasing. That's a section that's increasing. Again, because we're going up, then we go down, then we go up.
The numbers on the graph were really like what wasn't making sense.
So, because I think maybe it's the decimal, but this one is increasing from -infinity up to -3. It's how far it's looking at the x-axis. And then from -3 to 2, it goes down. And then beyond 2, it goes back up again. So it's based on the x-axis. So we can take a look at some more of those. There'll be some in the homework. We can do that tomorrow. So you'll need a graphing calculator for most of that. A lot of it is going to be calculating mins and maxes, things like that. So make sure you have your Chromebook so you can use that for the calculator. And we'll take a look at that first thing tomorrow.